dear students, welcome again to DAV Mall Public School. So let's begin where we left. Now, current electricity. Now you have to remember, now you have to pay attention very nicely and properly. Now current electricity means what? So every body, it is made up of matter. So matter is made up of fundamental particles, and it has fundamental property of matter, that is charge we have already discussed in previous videos. So charge that can flow is termed as current electricity. The flow of charges is called as current electricity, or the flow of electrons is known as current electricity. Electric current is defined as a rate of flow of charges or rate of flow of electrons. So the charged particle which can flow are known as current electricity. Simply remember, the charged particle which can flow is known as current electricity, or you can even say the electrons which are moving, that is current electricity. Or you have to remember this definition: electric current is defined as a rate of flow of charge. Rate is simply associated with time. So how much amount of charge is flowing in particular area or unit of time, that is charge. So it is represented by this formula. You have to remember rate of flow of charge. Rate, it is always time. Always remember rate. Whenever rate comes in any definition, it would be divided by time. So current, it is represented by symbol I. Now the definition of current says it is the flow of charge. So charge is represented by the symbol Q. So it is a rate of flow of charge, so therefore Q upon T. Now SI unit of charge, standard international unit of charge, is ampere, by the name of the scientist, ampere. CGS unit is biot. Again, a biot, a scientist name is there. You will come to know in higher classes about this biot. But electric charge cannot flow on their own. There has to be potential difference. Now, since I am saying electricity or current electricity means the flow of charges. This is the definition of charges. Charges, the rate of flow of charge is known as current electricity. Now, this electric charge cannot flow on their own. They always require potential difference. So now what exactly do you mean by potential difference? If the potential difference is there, then only electric charge will flow. So let us see what is potential difference first. Okay, we will see that potential difference first. We will complete about the current portion or the electric current portion. Now again, one important thing, that is 1 ampere. This 1 ampere are being asked n number of times. Yes, this 1 ampere are being asked n number of times in your previous board exams. Now how to define 1 ampere? 1 ampere, you have to simply remember this definition, that is I equals to Q upon T. Now simply write SI unit of all these quantities like I, Q and T. So I stands for current, so SI unit of current is ampere. Q stands for charge, so SI unit of charge is ampere, and SI unit of time is second. So you have simply written, you've got this as 1 ampere. Simply write 1, 1, 1, you will get 1 ampere. So this is a way you can remember 1 ampere. Now since you know how to make this, now you have to write that in terms of descriptive answers, descriptive point. So always remember 1 coulomb of charge. 1 coulomb of charge flows through a conductor in 1 second. Whenever 1 coulomb of charge flows through a conductor in 1 second, it is said to be 1 ampere. That's it. Again, this is I equals to Q upon T. You have to simply write this I equals to Q upon T in terms of SI unit. SI unit of I is ampere. SI unit of Q, that is charge, that is which is nothing but coulomb. Time is represented by second. Since you know that, you have to simply remember 1A, 1C and 1C. Simply write 1, 1, 1 over the SI unit, you will get 1 coulomb. And if you know this, you will construct the statement accordingly. When 1 coulomb of charge flows through a conductor in 1 second, it is said to be 1 ampere. Now again, certain quantities like large current and small currents which have been asked previously in your exams. Large current are those current 1 ampere is 10 to the power 3 milliampere, and 1 mega ampere is 10 to the power 6 ampere. So this thing you have to remember. Small currents 1 milliampere equals to 10 to the power minus 3 ampere, and 1 microampere equals to 10 to the power minus 6 ampere. Minus 6 is there, microampere. Milliampere 10 to the power minus 3. So this is the magnitude which we have to remember. Now all substance, basically the substance which we deal are basically electrical substance, are divided into three categories: conductors, insulators and semiconductors. So conductors are those substance which allows us flow of electric current. Those substance which allows electric current to flow are known as conductors. So all metals are conductors, like silver, copper. These are all conductors. These substances are conductors since all charges can flow in this element. Insulators are those substances which does not allow flow of conductor, like glasses, ebonite rod, rubber. These are certain insulators. Now, semiconductors, those substances which lie between conductor and semiconductors are known as semiconductor. Those which allow flow of current, flow of charges are conductors. Those which does not allow are insulators. Those substances which have property in between conductor and insulators are known as semiconductors, like silicon, germanium are certain examples of semiconductors. You might be knowing in periodic classification of elements about this element: semiconductors, silicon, germanium, arsenic, cadmium. These are all semiconductors. So many applications like silicon chip, which is there in your mobiles and all, germaniums, basically today's generation all work on semiconductors. So these are certain substances: conductors, insulators and semiconductors. Now let us discuss some more thing, that is electric field. So the space around the electric charge along which the electrostatic force of attraction or repulsion take place is known as electric field. So electrostatic force is nothing but attraction, and repulsion nature is an electrostatic force. Positive will repel, negative will repel, positive will attract. So this is an electrostatic force. So the space around which the electrostatic force happens, that is an electric field. For an instant, this is a proton with the positive sign, this is an electron. So this is a space between proton and electron. Here electrostatic, they are opposite in nature. So this electron is revolving around this proton. So here, because of this electric field, the space between proton and electron is termed as an electric field. Now next thing, that is electric potential. Now previously I told charges cannot flow on their own. So in order to flow charge, we require certain potential. So electric, that is nothing but an electric potential. So it is a point in an electric field. So this is an electric field. So it is a point in an electric field where the amount of work done in bringing a unit positive charge from infinity to that point. For an instant, this is a electric field. Infinite number of charge is located over here. So the work done in bringing a charge from an infinite position to into this electric field, a charge which is present outside the electric field, the work done in bringing that unit charge from infinity to into this electric field, that is electric potential. It is a point in an electric field, the amount of work done in bringing a unit positive charge from infinity to that point without change in kinetic energy against the electric force due to, that is electric field. This electric potential, it is denoted by V. Work done in moving unit positive charge from infinity to that point in an electric field is termed as an electric potential. Always remember, in an electric field charge, I am bringing a certain amount of charge which is at infinite number of location. So work done, a certain amount of work has to be done in order to bring that charge from infinity into this position. So that work done in bringing a unit positive charge from infinity into this field is an electric field, or electric potential. So electric potential, it is given by the symbol V. Work done upon Q, that is electric potential. Work done in moving a unit positive charge from infinity into that field. Now, as I was telling, this is a proton for an instant. Now, at extreme charge, a positive charge for an instant, if I am bringing a positive charge from an infinity into this proton, work done. So I need to do some work in bringing a charge from infinity into this positive portion. So in this path, I am drawing two more point rather, that is A and B. So work done in bringing a unit positive charge from infinity to point A or to point B, that is electric potential. So for an instant, if I consider this first as a point, this is a path in an electric field. This is the first path. So work done in bringing a unit positive charge from infinity to point A, that is electric field or electric potential. And again one more point, that is in that field I have considered B. So work done in bringing a unit positive charge from infinity to that point B is an electric potential. Now the next thing, that is electric potential difference. Now the potential difference between 2 points, over here one potential difference was there, one potential difference at point B was also there. So the potential difference between these 2 points, between A and B, is an electric potential difference. Again, let 2 point A and B as shown in the above figure, and in this figure I have considered 2 point A and B. If charge Q is brought from infinity to point A, so work done would be W suffix A. The potential at point A, the potential at point A would be it is written as VA. Work done in bringing a unit positive charge from infinity to point A, that's why W suffix A. Q stands for charge, so charge is going from infinity to point A, so the potential, electric potential at point A is VA, that is WA upon WQ. And with the same thing, now again I am bringing that Q charge but at point Q, but at point B. So the charge is I'm bringing that charge from infinity to point B. So if a charge Q is brought from infinity to point B, so work done would be W suffix B. Here I've named W suffix A. So this is point B. So I'm bringing my charge from infinity to B. So certain work has to be done. So that work done, I'm naming this work done as WB. And if I analyze potential at point B, it is nothing but work done at point B. It would be work done W suffix B upon Q. Q is going from infinity to point B. Work is done. That work is, I'm naming that work done as W suffix B, and point is moving from infinity to point B. So that therefore electric potential at point B is VB is equals to WB upon Q. Now if I take the difference between these 2 points, you have to simply take a difference between electric potential at point B and electric potential at point A. So that is electric potential difference. So the quantity VB minus VA. VB, this is VB. Always remember larger quantity minus bigger quantities. So this is the final quantity, this is the initial quantity. So VB minus VA, you have simply replace this value, WB minus Q, or WB upon Q minus WA upon Q. So you will get that this VB minus VA, this VB minus VA is the electric potential difference. Again, electric potential difference at point A and B, that is electric potential difference. Difference is there between these 2 points A and B. This was electric potential. The potential difference at point A and B is VB minus VA. So SI unit of this electric potential difference is again volt. Now charge flow from a body at higher potential to a body at low potential. Now always remember, charges always flow from a body of higher potential to a body of low potential. Now higher potential, as per the convention, positive charge is always at higher potential and negative charge is always at low potential. If I consider this as an electron, hold on for a second. Now, always remember, charges always flow from a body of higher potential to a body of low potential. For an instant, two bodies are there. This positive charge would always be at higher potential, and this negative charge would always be a low potential. So, electric current will always flow from a higher potential to a low potential. Electric current, whereas flow of electrons will flow from low potential to high potential. This is indicated over here with this ray diagram. This is a body which has negative charge, and this is a body which has a positive charge. So electric current will flow from positive to negative, whereas electrons will flow from low potential to high potential. Now, SI unit of electric potential and electric potential difference is one and the same, that is volt. Whereas CGS unit of both electric potential and electric potential difference is stat volt. One important thing about 1 volt. This 1 volt is being asked frequently in your board exam. Previously it was also asked. So 1 volt, you have to simply remember the formula for this 1 volt. Potential difference. This V is nothing but V is equals to W upon Q. So you have to simply remember the SI unit of V, W and Q. So SI unit of V is nothing but volt. W is nothing but work done. So SI unit of work done is joule, and SI unit of charge is coulomb. So you have to simply write B, J and C, and simply write 1, 1, 1. You will get a 1 coulomb. After writing this, or after defining this formula, you have to write this formula in terms of descriptive answer. So how to define this? When 1 joule of work is done in moving 1 coulomb of charge from one point to another is termed as 1 volt. 1 joule of work is done in bringing a charge from infinity to that point, that is, charge is moving from one point to another point, that is 1 coulomb of charge is being moved. So when 1 joule of work is done in moving 1 coulomb of charge from one point to another, it is termed as 1 volt. Now some large volt and small volts are also there. So always remember this magnitude. 1 volt is 10 to the power 3 millivolt, and 1 megavolt is 10 to the power 6 volt. So this is a certain large volt, whereas certain small volts are also there. 1 millivolt equals to 10 to the power minus 3 volt, whereas 1 microvolt is 10 to the power minus 6 volt. So these are certain magnitudes which you have to remember. So I hope you have understood this presentation. Thank you and have a nice day.